All right. So last time we did exercise 1 and 2. And this time we'll continue with exercise 3, I think. I won't be doing those mini exercises here. I feel like I want to move on to something else. So let's start by doing that. And we'll see what the AI cooks up. I'm honestly curious about what the next project will be. Roller code. An explanation. Awesome. Exercise 3 builds your loop muscles and introduces randomness, which we will lean on later when we sample tokens from an LLM. Exercise 3, dice roller loops plus randomness. What you'll learn while loops that run until you decide to stop. I think we did a while loop here as a bonus exercise on exercise 2. And then we have the wait, let me check something here. So, all right, and then break, exit the loop, continue, skip to the next iteration, and some more command handling, pseudo random numbers. That might be interesting. I've always loved doing like random number generations. Alright, create dice.py. A dice application. And close this one. I might as well close this as well. Alright, import random. I suppose that's a is it called a library or a, what do you call this? A module. So we import the random module and it says it's a random variable generator. Oh. And we define a function called roll_d. And a variable called sides. The returns an integer. Roll a fair die with sides and return the result. And we close this one here so we have more space to work with. Return random.rand int 1 sides. Inclusive on both ends. What does this function do? Return random integer in range. So it returns between 1 and this variable here. And I guess this means its default is set to 6. Yeah, we'll get to that. And another main function. None. Print dicer. Enter equals roll. S equals set sides. Q equals quit. Side equals 6. Optional uncommented next line to make roles reproducible. Same sequence every run. Wait. So might do that later. And then a while through. CMD equals input. Enter row. Wait. Oh. Dot strip. Dot lower. The strip function is familiar, but oh yeah, we will learn about this the last time as well. But I chose to do the dot title for the name application instead of dot lower, as it lowers all the string values, all the characters to lowercase. So if cmd equals q, print bye, and then we break. Leave the loop. Wait. I wonder why the distance is different between these two when I use tab. It's kind of annoying actually. And saving moves them closer. Is that one tab? No. It's 2 spaces. Alright. I'll just do 2 spaces from now on then. So the black formatter doesn't complain all the time. If cmd equals s, text equals input, number of sides, e.g. 620. Strip. Try new underscore sides, a new variable. Alright, what are we doing here? If cmd equals s, text input number of sides. Oh, so we are checking that the input was actually a number here with a try variable. Because here we have the exception and a value error. So if new sides is greater than 2, print, no, it's lesser than 2, of course, at least 2 sides, because we need 2 sides for the die. 2 sides would be more like a toying cost, I suppose. And we continue. Skip rolling, ask for command again. So if we reach continue, we skip rolling, which is the last step here, meaning that we go back to the start. So this is basically resetting the loop. Sides equals new sides, and the sides variable was the one we set up here. But if we reach this, then that means we've changed the sides variable to something else. And we print a formatted string, okay, using the sides. That shows our actual new size of the die. And here comes the exceptions for the value error. And then we print, please enter a whole number. And should we really put continue here? Huh? I thought continue would go in here. Because if we get the value error, then we print this, and then we go back to the start. But if we keep it out here, then it will automatically run even though we don't hit this value error exception. Oh no, that's the whole point. We need to go back to the top because we need to go do this menu step again, because now we set the sides and we need to go back to this one so we can enter the roll or quit. That makes more sense. Otherwise we would just go nowhere after we set the sides. So here default action roll. Value equals roll the sides. So we input the variable sides as a parameter in the function we created, and then we print a formatted string of the die size, and an arrow. I don't know how to do that, but just like this, I suppose. And a value. So it will say the die with the size we chose, cast, and became this value, or landed on that side, I should say. And that's everything, I suppose. And this is still inside the while true loop. So even if we reach this step here, we will go back to this menu here and do everything again in an infinite loop until we quit with a Q. And then the security check to make sure that we're running this as a we're running this directly and not imported as a module. Yeah, I think that's it. Dice.py dicer enter roll asset size q quit. Let's just do a normal roll. Alright, we'll land on a 6, nice. And again 5, again 2, again 4, again 3. And S size. And we do, I don't know, let's do a 20. Why not? Okay, using D20. Enter roll. 18, close. 16, further, colder, warmer, colder, warmer, warmer, colder. Yeah, whatever. And if we try to set the size as a non-integer, then it will say please enter a whole number correctly. Yes, and we try to quit. It quits with a bye. Bye. That seems to be working as intended. But this doesn't seem to work as intended. Confusing. And I'm just checking so the music is actually continuing and not simply stopping at the track end. Now it's working, it seems. Great. All right. And we've already tried this, how it works. I think this is pretty self-explanatory. Nothing here is completely unknown to me. It's working on the concept we learned in the previous exercise. So I guess this is unnecessary? Oh yeah, we had a random seed generator as well we could implement. So each time we start the application we actually get a random seed, so we don't have the exactly same roles each time we run the script. Random.seed 0. Why would I put 0 inside random.seed?
So the idea behind using something like random seed 0 is basically to get a repeatable sequence of random numbers. When you set the seed to a fixed value like 0, the random number generator will produce the exact same sequence of numbers every time you run your code. That can be super handy for debugging or for when you want consistent test results.
I mixed it up. It was already random, but this sets the seed to 0, so each time we can uncomment this line to make the roles reproducible. I forgot all about that comment, so I suppose this one is unnecessary. There's no need to have a static seed. Alright, stretch goals. Optional, pick one. Let's do one of them. Quick frequency table, fairness check. Add this function to the file below roll_d. Then call it from the main by typing command sim. Def simulate. Alright, let's write that out. I'm not entirely sure about what it does, but I think I have an idea. Counts 0. times sides plus 1. Ignore index 0. Or I'm not gonna lie, I'm getting a bit confused the more I type. Counts, roll the sides plus 1. Side S. I was wondering why they complain in red on the score. Alright, let's think through this step by step. So we define a function called simulate, and we have a parameter called n, and we want to pass it as an integer. And we have another parameter called sides that we want to pass as an integer as well. And we want to return nothing. And then we have another variable called count that equals 0 times sides plus 1. Ignore index 1. I have no idea why. Wait. No, I'm still confused. 4 underscore. This is a horrible variable name, in my opinion, but maybe that's a standard way to use a for loop in Python. Whatever. For each of this value in the range of n, which we set here, do a count. I think I need to see this in action before I actually understand what is going on. Let's continue. Print and simulated and rows of the sides or facing range. ECT plus 100 times counts base divided by n. N. And we print a formatted string. Alright, this is gibberish to me, honestly. And I've done a syntax error somewhere. Am I blind? Oh my god. Are we for real? I didn't even notice. Alright, so after this we print similar to end rows of the side for... No, I need to see it in action. I stand by what I said before. This doesn't explain anything to me yet. Then in the loop add I suppose we can do it here. If command dot starts with sim, if I don't misunderstand this, then go into the sim and typing something like, I don't know, 1000, then that means I will roll the dice 1000 times. Or simulate myself rolling it 1000 times. But that's pretty self-explanatory if that's the case. So I don't know. Run sim 6000 and you should see uniform percentages. Why this matters later. When sampling tokens from an LLM, will also watch distributions. This allow huge dice. Alright. This is another function for a string variable then. Starts with, so if I type sim or simulate or simulacrum or Simpson or whatever, then this will be run before we go back to the start. Parts equals cmd command dot split. Return a list of the substrings in the string using sep as the separator string. When set to none, the default value will split on any white space. So I guess that means this variable counts how many words I inputted. If I say like I wrote simulate, I don't know, simulate, I don't know, let's go with that. That's 3 words. Simulate, I don't know. Then the parse would be 3 variable. An integer of, no. Does it return a integer? No, it returns a list of the substrings in the string. So this becomes a list strings, as it says. And then we have the integer n. We convert the first. Alright, I need some explanation on this. Explain this. I don't understand what's going on. I don't understand, what does it simulate? It should simulate dice rolls, but why? Or how? What this function is for? It simulates rolling a die with sides n times and prints how often each phase appeared. That makes sense. And that also makes sense in the context of an LLM, as that has to recognize patterns. Often each phase appeared plus the percentage of each phase. Line by line, def simulate, and so this one here, a function that takes n how many rolls to simulate, makes sense. Sides, how many sides the die has, also makes sense. And hints, yeah, we don't return anything. And counts. I'm really confused about this one. Creates a list of zeros. Oh, so this means it's a list. And the length of the list is sides plus 1. Why plus 1? Die phases start at 1, not 0. While making the list one element longer, we can store the count for phases k at index k. Index 0 is unused, convenient but slightly wasteful. Oh, I think I get it. Yeah, that makes sense. So if we call for the... We need that to be able to reference the item in the list correctly when the die phase is at the end. Since the list starts at 0, we need to add another item to the list to make sure we don't run out of items when we call on it or add something in it. Example for a d6 count starts as 0, 0, 0, 0, 0, 0. Index 0 is unused. Indices 1 to 6 are the phases. So these ones are the phases, and this will be unused. Because then this is the first. This will always be 0, no matter what you do, but this will be 1, 2, 3, 4, 5, 6, and that matches with the 1 to 6 phases on the die. For underscore in range n, loop n times. The underscore is a common Python convention for I need to loop count but won't use it. So I guess that answers my previous question. If that's a standard way to do it. Counts roll underscore d sides plus equals 1. Plus equals 1, adds a number. adds one integer to the list, or to the value in the list. Roll underscore d sides returns a random integer in one side. We use that as an index and increment the count for that phase. After n iterations. Counts k holds how many times phase k appeared. Oh, I think I understand. First, when we're at this position, we call the roll underscore d sides, which returns a random number between 1 to 6 if it's a 6-sided die, and it stores it in this position. And then we add an increment to counts, meaning that we're on this position, but this position is still empty, but we're on that position then. And then next time we go through the for loop, we will run this again, and then it will be this position that gets filled, and then we increment it so we are on this position for the next loop. At least this is my understanding. I might be wrong though. And then we have the formatted string we print simulated, and this is after we do this. So we know how many rolls we've simulated of the die. Prints a header. Alright. So we had a blank line to the command line interface. And then for phase in range 1 sides plus 1. Iterate through phases 1 through sides, inclusive skip index 0. Alright, so PCT, computer percentage for that phase. 100 times count phase divided by n. As n is the total number of iterations or the simulations. Counts phase. I feel like this is going a bit too fast. I mean, we have lists and we have all these calculations and math and stuff coming really out of nowhere. I suppose it's irrelevant, but it's really dense and quite a challenge to get my mind around. Print. This is a pretty formatting. Write a line in a width of 2, so I honestly feel like I need to see this in action before I even begin to grasp all the minor nuances. And I suppose I could just wait, do we set n anywhere? Let's just run it and see what happens. So if I write sim, how many times did we simulate these rolls? Does this mean we simulated 1000 rolls in just this segment here? Or does this mean we... So this gibberish here is only to get it to look like this. So face, and this means we have 4 spaces for some reason. Oh, here we have a space as well. No, I'm not even gonna try to understand this. Right line with a width of 2, so 1, 2, 10, etc. Right align. Counts. Base. Let's see what the AI says if I do this. I'm still confused. This is the first time we're going through lists, and on this iteration, and math is kind of going over my head. I don't know if it's just because I'm really tired or why, but I can't grasp this. It feels like something is wrong with my brain. Alright, let's do this. It might make me understand what's going on, so... It's a new file. Dice step by step. I mean, I understood the normal die function perfectly. This wasn't difficult to understand, but this simulate stuff, it got really dense really quickly. Dives. Alright, let's do this. Import random, define roll d6. Return random.randint between 1 and 6. Random, inte not random, random. Def demo score rolls. None. Print rolling 5 times just to see results. For I in range 5. Repeat 5 times. Base rolls for d6. Get a number. Print if roll I plus 1 base. And then the security check. Demo underscore rolls. Alright. So this function here returns a random number between 1 to 6. And this function here rolling 5 times just to see results, yes. And we have a for loop here, so for I in range 5 repeats 5 times range. Is that another variable type? Is a class. Return an object that produces a sequence of integers from start. Oh, yeah, a range. So it's basically an object that's 5 in length. Or it contains 5 items or 5 slots or 5 points, and we iterate through each of those points. I don't know, I'm saying points because I don't know if we can actually use range for anything or if it's like an empty variable that only contains like a length. Maybe step is a better word. So for I in this, each step in the range, we set the variable phase to the random number between 1 to 6 that we get from this function here, and we print the iteration number we're on and the result. So the first roll would be roll 1 and then the random number. mm, oh. Python dice step by step by. Yeah. And if we did something like this, then we would need to press enter each time just to see the result. To space it out a little bit more. That's just to see repetition and randomness. No lists, no math besides printing. Step 2. Count with 6 separate variables. No lists, no dictionary. Append this to the same file below demo rows and call it in main. So count with variables n int equals 10. None print f and counting with 6. Wait, oh. Counting with 6 variables over n rows C1 equals C2 equals C3 equals C4 equals C5 equals C6 equals 0. I've never seen one do variables like this, but I suppose it's a quick way to set all the variables to 0. 6 counters all start at 0. 4 in range n. And n is the parameter here, or the variable that I think defaults to 10 if we don't set it ourselves, but we could change it to something else, I think. Base roll d6. This is sloppy code, but we had to start somewhere. Five or else base equals 6 C6 plus equals 1, like that. And then we print, no, not inside the loop, outside the loop we print counts C1, C2, C3, C4, C5 and C6. And here we do count with variables, and here we set it to 20. And 20 was the number of rolls. Alright, let's try it. Counting with 6 variables over 20 rows. So we had 4 1s, 4 2s, 3 3s, 3 4s, 4 5s, and 2 6s. And this should add up to 20. Wait, no. Yeah, 20. 8, 11, 14, 18, 20. That makes sense. We can run it again. And we have a different number of counts. Different again, different again. Different every time. This is 100% understandable, just verbose, yeah. This is easy to get. It's just a bunch of if statements that manually checks each side and then adds it to the counter for that side. Alright. Step 3, same idea but with a dictionary. Easier than lists. A dictionary maps keys to values. Here key equals face, value equals count. So I guess the keys will be like 1 through 6. 1, 2, 3, 4, 5, 6, yeah. And all the values here start at 0. Def count. Wait. I'll be right back. I'm back. Alright. Step 3, same idea but with add dictionaries in a list. Yes, we did already said that. Yeah, count. Or I forgot what I was doing. Count with dick. Count with dick. And int equals 10. None. None. Print a new line with counting with a dict over n roles. Counts equals curly brackets 1 with a value of 0, 2 with a value of 0, 3 with a value of 0, 4, wait, yeah, 4 with a value of 0, 5 with a value of 0, and 6 with a value of 0. And this is complaining, oh, because it's never used. Yep. 4 underscore in range n. So we loop through the range, through the numbers of n's, the number of n's, through the length of n. And we assign the face value to the value that d6 returns. And then we assign I think this is what's tripping me up. We have a dictionary here, and this is the value we get from rolling. So a value between 1 and 6. Oh, now it makes complete sense. So if we roll, let's say a 6, then the face value is a 6. So we go into the count dictionary, and if the value was 6, then we are here, and then we add 1 to that number. So this would be like this if it was the first time looping through and we got a 6. That makes sense. And then outside the loop, do we just print the... Yeah, we print the whole dictionary like we did down here. And then we do some pretty printing. And we had range 1 to 7. Instead of, it's still a range of 6, but it's still a length of 6, but we had the number will start at 1 instead, because we have it starting at 1 here. if we just used range 6, then the first phase would be a 0, which doesn't exist in the counts dictionary. So we need to do it like this to loop through each phase, or each loop through each item in the dictionary. And this will basically only print like a, let's say it's a phase. If it's the first phase, like a phase of 1, then we'll print how many times that phase appeared afterwards. Because this prints the value stored, which we set in this loop here. Alright. Count with picked 20. And let's try it out. So here we have the count with the dict, so 20 rolls. And it prints it like this. So we can see here. And these correspond to each other, so we can read it here instead. And we could basically just do this if we wanted, and then only get these numbers instead. But let's keep it like that. Oh yeah, here it shows it even. This is often easiest to grasp. Look up the bucket by name. 1 to 6 bucket. Is that the word for an item in a... Do you call an item in a dictionary a bucket? Hello? Do we call an item in a dictionary a bucket? Hello? Do you call an item in a dictionary a bucket?
In normal Python terminology, not really. Typically, you just call it a key value pair or an entry. Now, behind the scenes in the way dictionaries are implemented, there's a kind of concept of buckets in the hash table, but you wouldn't call each dictionary item a bucket. So short answer, nope, you just call it an item or a pair.
So when you said this is often the easiest to grasp, look up the bucket by name, 1 through 6, and add 1. What does that mean?
Ah, I see what you're getting at. So sometimes people use the word bucket a little loosely just to mean a category or a slot. In that kind of informal context, saying something like look up the bucket by name is just a casual way of saying look up the category or the key. It's not the standard term for a dictionary item though. So basically, it's just a figure of speech.
And what was the standard name for an item or key in a dictionary?
So the standard way you'd say it is just a key or a key value pair. Basically, each item in a dictionary is a key that maps to a value. So if someone was talking about a bucket, they probably just meant a key or one of those key value pairs. That's the usual terminology.
Can a dictionary have only one key value pair?
Absolutely it can. A dictionary can be as small as just one single key value pair. It's totally valid. So if you've only got one thing you need to store, that's perfectly fine.
Interesting. So we could have like only we could have like a dictionary that's this big in size. Alright, step 4. Same idea now with a list, introduces indexing. A list is like boxes in a row. Each box has an index starting at 0. We want to store counts for phases 1 through 6, so we'll make a list with 7 boxes and just ignore index 0. That way count for phase 3 lives at count 3. This makes sense. Otherwise, if we used count 3, then we would actually get the 4th key value, or the 4th key. This would be the 4th key, and we would get the 4th value even though we say 3, which we don't want in this context. So we do another function, define function count with list. Oh, I think I understand what's going on here. I think so. So counts becomes a list here, and it's 7 in length. That's why I use the multiplication, and this is the value of each item in the list. That makes so much sense. Alright. And we do it 7 in length to skip over the first item and keep that at 0 later. And then 4 underscore in range. We do a standard loop. Oh, old habits. Base row. And this is actually the exact same thing we had here. So we're just looping through the list and assigning a randomly generated number from the roll function to each item in the list. And then we print counts list. Counts. 4 phase in range 1 through 7, print f phase. And yeah, this is the same as last time. And let's run it again. Counting with a list of 20 rows. Yeah. Why would anyone use a list here? It's memory and speed friendly when your keys are dense integers 1, 2 through n, but for learning the dict version is perfectly fine and very readable. So using a list is more efficient, but a dictionary might be clearer? Maybe? Alright, step 5. Percentages the only math here. Way to call me out. If you roll n times and phase 3 appears k times, fraction equals k divided by n. Percentage equals fraction times 100. The part divided by the whole. That makes sense. Why is this all green? So annoying. Nah, let's do it beneath here, just to keep it in the same order. Right, def count with dict and percent. What? That has to be a typo. I mean, this makes sense. The previous... this doesn't make sense. Let's just ignore it and continue with the code. So a for loop. All right, so we establish a dictionary. Or am I wrong? No, this is a dictionary. And oh yeah, this makes sense as well. So for instead of writing it like we did up here with 1, 2, 3, 4, 5, 6, we do that automatically by using this little piece of code here. So this is a tiny for loop. So we basically just set values 0 to 7. No, we don't, do we? Or do we? Is it 0 to 7 or 0 to 6? I do like a no. Let's ask it for clarification. Does this tiny for loop set each key to I with a value of 0? And does that mean that the first dictionary value is 1 and the last dictionary value is 6? That 7 is throwing me off. I mean, I know the range is only 6. Wait. Yeah, key. Yeah, sorry. Yeah. First thing. I said key here, then value down there. Okay. Expands to 1, 2, 3, 4, 5, 6. Range 1 through 7 yields 7 is excluded. Is the last number in the range always excluded? This is the first time I'm hearing about this, so I'm a bit confused. Yes, in Python, the stop value in the range start stop step is always excluded. No matter the step, positive or negative. Think half open interval start stop. List range 5, 0 through 4, stop 5 excluded. Oh, alright, that makes sense. I thought it was like the range was 5, and I mean this is a range of these are 5 numbers. 0, 1, 2, 3, 4. That's 5 numbers. So that confused me because this isn't 7 numbers. It's 6 numbers. Oh, we can do a range, a negative range as well. So 0 to 6. Start at 6 and end at 0. We go back by 1. But then we end at 1 and not at 0. And these are indeed 6 numbers. So, alright. I think my confusion has lifted somewhat. This is completely new to me with the step modifier or step argument parameter. Alright, what were we doing again? Oh yeah, back to this. So we loop through the counts, which looks identical to this one here, and we add values to all the keys, and then we do the same, but For the we do the same but for the value instead of the key. So k equals counts face PCT or percentage equals 100 times the parts divided by the whole. Okay, divided by n. Print equals face k, which is the value, and then we print the percentage PCT and it dot to f signifies something. Which I don't remember. Explain this. You're looking at an f-string placeholder with a format specifier. F-string, yes.
I'm
Is it
sorry,
T?
but you've hit the daily
Oh.
limit for advanced voice.
Jump scared. Ooh. Damn, that scared me. Yeah. Alright, so the float value is very long and source the format spec. Alright. Fixed point number with 2 digits after the decimal. Fixed point decimal. Point 2, precision 2, it rounds to 2 decimals. Outside the braces, just literally the present sign added to the, that makes sense. And minimum width right line. Pads, so the whole number is at least 5 characters wide. I don't really understand what you mean by padding it. I suppose it doesn't matter. I can ask later if it comes up again. Built-in percent formatting. Okay. But this should be working now. Let's try it. No. But we also have to count with this as well. Like that. And yeah, because we left this. No, wait. No, wait. Yeah. We already set like the first key value in the dictionary to 0, so I thought this was the first key value, but no. It was just randomized that way. And you see each face near. Okay, so let's try that. Let's do, I don't know, 10,000. Might be overkill, but let's try it. Yeah. Alright, and then your turn, tiny tasks. Change n to 2 in each function and run. Watch the counts is the reason about with so few rolls in the dict version. Print the dict after each roll, see it grow. Why? Why would I do this? Change n to 2 in each function. Why would I do this? What's the reason? Oh, completely forgot about my chest. Oh, a new item. A hat. You can track every step in your head. With 2 rolls you can see exactly how the loop runs and how to counter changes after each roll. No mental overload. It proves the wiring is correct. You'll verify each roll increments exactly 1 bucket. And the sum of counts equals n. No, the sum of counts equals n. Bases are always 1 through 6. Boundary check. Dict keys or list indices are used as intended. Spot off by 1 mistakes fast. Spot off by 1 mistakes fast. Bugs show up immediately. Accident wrote the rand int 1 through 6 or range 1 through 6. A tiny n makes the error obvious. With small n, you're learning mechanics, loop, index implementation. After that makes sense, you turn n up to 6,000. See the distribution flatten, love the large numbers. I mean, I understand that the distribution flattens if you do it a lot of times, because that's just how math works. Like, you will get a lot more noise the fewer times you roll. Because each roll has more power, I would say. Or that might not be the best way to put it, but it makes sense in my head. But I don't understand why I would do it now. I'm not going to write this, I'm just going to copy it and paste it because I don't understand what the point is with this. And let's set that to 2. And run it again. Alright, so roll 1. Wait. Roll T in range. Maybe I should have written this, because this makes... What do you mean import random? Why would I import random here? I've already done that. Count. Alright, so we set a dictionary here, and we make it 6 in length with values of zeros, and then we loop through. And we use +1 here to make sure, because we're starting at 1. And n is how many rolls we're doing. So for each roll we loop through this, and we set the phase to a random number between 1 and 6. And then we set that value inside the dictionary before we increase that value inside the dictionary. And then we print which roll we're on and which phase. Or no, we print which phase was added to the counts. Yeah, we print which phase was added to counts. And since it was 4 both times, we get a value of 2 in the key 4. Then we will do 20 here. And like this, you can see the values here, and then we finalize at values 2, 3, 5, 5, 5, and 0. So we got no 6s this time. Oh yeah, the seed is also locked, so we can check how long it takes for us to get a 6. And we got the 6 at roll 21, so we just got really unlucky to not get a single 6 on 20 rolls before roll 21. I suppose this was a useful little exercise. Yeah, I should have written this myself, but whatever. I didn't think this would be useful at all to visualize it, but it actually was pretty useful. Alright, and where were we? Oh, right, the dice, okay. Another question is, can I understand what is going on? Okay, so we have the roll D function and the simulate function. So n has to be the what do you call it, the roll number, or n is int parts 1 if... Oh, this is still confusing. This is still confusing. What does this do though? Great line to zoom in on. It's a conditional expression, also known as a Python's ternary. What it means, step by step. Parts is a list, likely from parts in the... Yeah. Sim 5000 equal to sim... Oh. Oh, yeah, alright, okay. So it defaults to 1000 if I don't specify how many times. Which it says here even. Can't believe I fucking didn't even notice that one. I even wrote a fucking comment, but it didn't even register to me. Okay. Okay. Damn. And here we have len parts. Checks whether there's a second token. If true, user type a number. Yeah, if false, no, I given use default. So, okay. So if wait, if len parts. Oh, so we set this if the len, I think that means length, or am I wrong? If the length of parts is greater than 1, if we have like sim, this is obviously one item, and if we have 2 items, then if we have 2 items, then we do this. Otherwise, we do this. The syntax is a bit confusing, but I understand it now, I think. And the sides is something we set here, yeah. And the simulate function counts equals, this becomes then a list of zeros. That's sides plus 1 in length. So we can ignore index 0 later. And then we loop through all the simulations, and on each simulation we add the roll value. Then we add 1 to the roll value. No, to the rolled key. Wait. We add 1 to the value attached to the key. I'm probably just confusing myself right now. Counts. I mean, I understand what this does, but I'm having a problem like spelling it out. So count is a list, and for the key we get when we roll, we add 1 to that. And then we print how many rolls we simulated of the die. And after that we print after that we print the percentage. For each phase. Or each key, should I say. I don't know if that's correct, but we print for each phase. And that's everything we do, and the result is... Wait, is this? No, it's the same terminal. Okay, so dice. Sim. We just do sim, then it's 1000 rolls. And yeah. And if we do sim 2000, just 2000 rolls, or 20,000. Damn, this is actually taking a while. And we're really closing in on the 16.69, I think the value was. Or something like that. No, maybe not. 16.61 maybe. Oh. No, probably 16.69. Anyway. Yeah, I think I understand it actually. Great. That took a long time though. That was only one exercise and we're at almost 2 hours. Though this was a bonus exercise, which was pretty long. Just to understand the third exercise. Yeah, I'm honestly too tired to continue for today. It's been a long day. And I need to let my brain decompress and just consider everything I've learned here. So I don't forget everything for the next time. I'll probably be streaming tomorrow as well. Just to keep everything fresh in mind. Yeah. That's it for today. Have a great day.